Hello everyone. I am Mithun Kumar G from Savita Engineering College, currently pursuing BTech in Artificial Intelligence and Data Science. In this video, I will be demonstrating the push button and the LED control experiment using STM32 microcontroller. I have implemented this experiment using both Proteus simulation software and the STM32CubeIDE for programming and debugging. The main goal of this experiment is to understand how to configure GPIO pins for input and output operations and how the STM32 handles simple digital signal interaction in an embedded system. The objective of this experiment is simple but very important: to turn an LED on or off based on the status of the push button switch. The concept behind this is the digital logic control of microcontroller pins. The push button provides a digital input signal, either high or low, depending on whether it's pressed or released. The LED acts as a digital output device which turns on when it receives a high signal and turns off when it receives a low signal. By combining these two, we can control the LED state dynamically through software by reading the push button's input value. Now, let's move on to the code. At the beginning of the program, we include the necessary header files like main.h and initialize the hardware abstraction layer, which allows us to access microcontroller peripherals in an easy and standardized way. In the system configuration function, the system clock is configured using high-speed internal oscillator. This ensures that the microcontroller runs at a stable frequency. Pin A5 is set as an input with a pull-up resistor, so it stays at logic high when the button is not pressed. Pin A11 is set at output push-pull, used to drive the LED. Now let's see the simulation part in Proteus. I have designed the circuit by connecting the push button to pin A5 and LED to pin A11 of the STM microcontroller. A pull-up resistor is used to ensure that the button gives a stable high signal when not pressed. When I press the button in the simulation, the LED immediately glows, and when it released, the LED turns off. This confirms that the program is functioning correctly. The STM32 is detecting the button's state and charging the LED output in real time. The same logic works when deployed to actual STM32 hardware. Pressing a physical button would light up the LED instantly. Let's briefly understand why this happens. The GPIO input pin senses voltage levels. A low voltage 0 volt represent logic 0 and high voltage, for example 3.3 volts, represents logic 1. When the button is pressed, the circuit connects the pin to ground, making it logic 0. The microcontroller then turns on the LED by setting the output pin high. When the button is released, the pull-up resistor brings the input back to logic 1 and the LED turns off. This illustrates the principle of digital signal interfacing, a fundamental concept used in embedded and IoT system. Through this experiment, I learned how to configure and use GPIO pins in STM32CubeIDE, understand input-output data flow, simulate hardware behavior using Proteus, and test embedded code without needing a physical setup initially. To conclude, this project successfully demonstrates the working of a push button controlled LED system using STM32 microcontroller. The code, hardware configuration and simulation output all confirm the correct operation of GPIO input and output. Thank you for watching my video presentation.